So, ObjectBox is a new database. It's an object-oriented database. And this is like a real preview for iOS, macOS. We are coming from Android and like desktops, and this is like our next step. So, first off, we're not built on SQLite, so this is really like a fresh start. If you think about SQLite, it's like from 2000, and Core Data, I think, has its roots like 1994, something like this. So it's really like robust, but also a little dated technology. So ObjectBox is really a database designed for objects. So if you would build a database today, how would it look like? Whoops. Okay. So, and for iOS, we really want to focus on Swift. So have the best Swift support we can have. And think about Objective-C only in second place. And simplicity is a major theme, so we want everything to be as simple as possible, as transparent as possible. So this means like there's no NS-managed object at all. So it's really plain Swift objects. Also, we have those contexts which are thread bound. We don't have that. And the major theme is also performance. So like on Android and desktop, we're like the fastest embedded database you can get. And we're also targeting not just iOS, but also macOS and all the others. So it can be like up to around 10 times faster, and like in absolute numbers, that would be like you can have like 100K entities, bulk operations per second. So you can operate on a lot of data. Also, if you think about mobile, so you can pull more data onto your device. And ObjectBox, like the name alone, already tells you something about the API. So we really wanted to have a simple API. So you put objects in a box to persist them. You can get them out of the box or remove them from the box. So this is how our API looks like. So this is like a code example. So first you need to acquire a box for a Swift class. So, and with this box, you can just create an entity and put it. And onward, it's persistent. To get it out, you would just say get. And this is how a Swift entity looks like. So it's a regular Swift class, there's no NS object in it, and even like the entity protocol, that's optional. You can just have no protocol at all if you want. And if you think about your your app architecture, you probably have some UI logic layer and app logic, maybe some storage logic, and you still can use like those entities across all those layers. And even, for example, storage logic might be a separate thread in your UI thread. You can just pass around those objects to that layer. So you don't have to do like all those contexts at all. So ObjectBox is pretty fast. So like a frequently asked question is, is it like a in-memory cache or what is it? No, it's like a real database which is transactional and has full asset properties like atomic, consistent, isolated, durable. So how it's working internally, there's like multi-version concurrency. This means that you can have multiple readers at the same time, they don't block each other, and you can have a single like writer, like a write transaction, and they never block each other. So this, it can just go on. And there's also like implicit transaction. So for each put that you do, this is a transaction. And put is overloaded, so it doesn't matter if you have like a single object or like an array of objects. But of course you can also have explicit transaction, then you can just call running transaction, have a block, and this block will be transactional. So, some internals. So for iOS we faced a specific challenge, which is like we have like way too many languages. We have like C++ is our core. We have some C, let's skip that. And then we we want to do Swift first, but there's no way to talk from Swift to Objective to C++. So only Objective C++ can call into C++. And on the other hand, there's also like Swift, which can call only into Objective C. So there are, and also like Swift. So it's really a little complicated. In the end, we settled, we figured it out. And one important thing to this is like you can have like a Objective C++ class, and like those Objective C protocols, like pure C, those can be implemented by the C++ thing. So, and that helped us a lot. Also, exceptions were another challenge because our core product uses those a lot. And as you may know, like Objective C, like the connotation of exception is totally different. There's nothing that you catch. It's when your app dies. So it's done with NS error. Also, like Swift has some exception thingy, which is not really exception, but it's like nice syntax for wrapping NS error, something like this. So what we do, we catch C++ exceptions. So we have like a single code point for that. So we use blocks to do all the error handling in a single place. We say this is our block, please execute, and this method will do all the exception mapping. And there's also some nice stuff we do with code generation and sorcery. But why do we do that? So we want to put Swift objects, but like the main code within ObjectBox for iOS is Objective-C, and there's some mismatch kind of. So there would be a way where we would require Swift objects to be NS objects, but we didn't want to do that. So we really want to say Swift first and no strings attached. So what we're doing to do this is sorcery. Like, can I have like hands up who knows sorcery? A few hands. Okay. It's basically based on your existing Swift code. It's like parsed with Apple Source Kit. You can generate code, and this is like a great use case for ObjectBox because you can scan your entities and generate like the glue code to create exactly with Swift object or to save this Swift object. And this is really great because we can do this at compile time. So during runtime, there's no performance penalty. And this is just like on the Android platform, that's like super crucial because it's very slow. It's not as bad on iOS, but still there's really performance gains. Also like startup time, there's no introspection or whatever. Okay, so today we like made our first benchmark. So all what you're seeing here is very, very new. It's like the first time for us and me. In many ways, the first time iOS Meetup and first time we present ObjectBox for iOS at all. So let's have a look at our results from today. What you will see in a second is like entities per second. which is so big is good, right? And we will just compare ObjectBox with Codegen for typical bulk operations like insert, update, and read. And yeah, it really is faster. And Codegen is a great product, but it's also very complex. And it can be streamlined in so many ways. And that's also one of the reasons ObjectBox exists, because the same is true with, on Android, for example. So we still have to check those results. Yeah. So we want to publish those like open source, so more people can look at it, because it's so easy to make a really stupid mistake and all the numbers change. But yeah. So for read, it's like 46 times faster, which is a lot. If let's see if we make a stupid mistake, but we should be pretty much like a magnitude faster. So what's next? So all what we have now is like a vertical functional slice of ObjectBox. So we can persist an entity and get an entity out, or like an array, and this is like just the first step, and our path is pretty long. So we need still to work on basic operations and figure out how we have code generation integrate with it completely. And next up are like relations between objects. Oh yeah, and by the way, like relations is really built for relations also. Like queries for relations, it was also like in Android, it was like 50 times faster. And yeah, queries is a big topic with a lot of stuff coming up. And also we want to look, is there something specific in Swift that we can really have in a great way for developers? And also if we think about not just using data for its own sake, but how you use data with your UI. So this is also something we want to think about. And yeah, so what you see here is like a data browser. This is like all written in C++. We just need to figure out some things, and it will be on iOS as well. Yeah, so one of the real reasons I'm here is that we really need you, because we really want to have feedback. So we are thinking, okay, we should work like this, but we want to have feedback early on. So please let us know what you think about it. You can just come to me and talk, or have an email later. And also we still have like many APIs to fill yet. So this is like I love those challenges to design an API that is really simple, and maybe you also have some great ideas. And at some point, when we go for alpha testing, we might start public, then maybe even like have a private with alpha round. And of course, we are also looking for new team members. Yeah, so that's about it. Like the company ObjectBox, we have been to Techstars. That's one of the main, like the better known accelerators last year, London. Like Vivian here made second place at Slush. That's like the biggest startup conference. And we are with Black Box Connect, which connect us into the Silicon Valley, Google Entrepreneur, and so on and so on. And we really love GitHub, even with Microsoft, I guess. Yeah, okay. That's it from my side.
So about the roadmap, when do you think that you will have a 1.0 release?
This year.
And will it be, will you have like a price model, or?
Yeah, good question. Like the pricing, database is free forever.
Okay.
So what we want to do, how we want to make money is like persistence is the first step, but where does the data come from? Probably from some server. So we want to also make this a lot simpler with data synchronization. Not like Firebase, which is like a break in your object model. We really do objects from end to end.
When you write your query language, will this be like built into the language itself, or will you write your own language like SQL, which I can reuse then maybe on different platforms and maybe in the web of the database when it's on your servers? I don't want to write all this code again just for my query, for example.
So we want to stay like in object-oriented land. So that's why like our initial idea is like have a query builder API where you can, but also at that point we can use like the generated meta information. So we can have like type safe things. For example, if you have a person class, you might have a property with birthday. So you could write where birthday, which is like generated property, dot equal whatever. So no strings that you can mistype. So this is like the first idea. So for example, NS predicate is something, we don't know. So that's also where we want your input.
Second question about migrations. This is one point I missed. Right now, I work a lot with Codegen. I work a lot with core data personally, and one of the hardest things for me is like migrations. Most of the time I have to write my own because I can figure out things. Do you have any plans already, or do you have some kind of concept how you would make migrations possible? So transforming data from one scheme to another? Is it planned at all?
So like 80% of the use cases is that you either add a property, add a new entity, something like this. So this is fully automatic. So it just it will get like all the information, like the data model information, and it will just try to update on the fly. So if you rename a thing, it's different because it cannot tell is it like a remove and add, or is it a rename. So this is where you have to tell, okay, this is like a rename, and we want to have like those sorcery annotation like comments for that.
How does this compare to Realm? You mentioned, the comparison
Yeah.
you presented was the against core data. How does this compare to Realm?
So how Realm started, they wanted to be like a better SQLite. So what they do is, we still have like rows and columns down at the C++ layer, and we totally broke with that. We don't have any rows, columns. We're more like a key value store at the bottom. And this is like the better approach for object persistence. And this is like one of the main reasons why we were that fast. So if you look into like serverland, the fastest databases you can get, key value stores. Also, Realm is like a little older. For example, I think they require you to use NS objects, and they have also those threading constraints and so on.
It's fully dynamic.
So,
Objective-C.
right. So, and that's why we're focusing also a lot on Swift, because this is like our chance to rethink objective object databases for Swift.
The product's a bit further along on the Android side by the sound of things.
Yeah.
I wonder if maybe you could just talk about how the whole, where it is on Android and how that experience has been for you and things.
Yeah. So I guess we are at version 1.5. We are used by big apps that have millions of users. So running on thousands of different Android devices, like fragmentation is a bigger issue, of course, on Android. So in the first place, of course, we had to get stable and all that stuff. So we went a pretty long route already on Android, like integrating a lot of user feedback, and we were still working on like features for Android to get it further. But at the same time, we're also like having 2 side tracks now, like iOS and also data synchronization. Okay, so if there's anybody who wants to have a closer look or something, please talk to me. Okay, thank you.